Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and today we're going to do part 3 of Laws of Exponents. So we are going to focus on fractional exponents, but we're going to throw in negative exponents and some of the other rules we've learned in the other 2 parts. When dealing with fractional exponents, we actually have 2 rules, and they're our last 2 rules of Laws of Exponents. So we're going to start off in continuation from our other rules. We're at rule number 8. It's a to the 1 over n. So now we have a fractional exponent, and I want to define what that means. Typically, we're going to leave it as 1 over n, and we're not going to write it this way, but I want to explain what it means so that when you see it with numbers, you know how to handle them. What this means is the nth root of a. So it's a notation that's used to help us represent radicals. This whole thing, whenever you get into root signs, that's called a radical. And they're harder to work with, so we'll often change them to powers with fractional exponents, and then we can use our laws of exponents to do our simplification. However, I want you to understand what it does mean if you had a number. So if I had, let's say, 9 to the 1/2, what that means is the square root of 9. When it's square root, we don't have to put the 2. It's understood to be a 2. If it's a 3 or a 4 or any other number, you need to indicate that. Square root of 9, we can then simplify. So I want you to understand what it means in terms of numbers, but when you see this in an algebraic expression, you're going to leave it like that. You don't want to go to the radical form. Okay, let's take a look at some examples. All right, let's take a look at our next example. We have y cubed times y to the 1/2. We know that when we have 2 powers multiplied and the base is the same, we can add the exponents. So we're going to have y to the 3 plus 1/2. Now, you've learned before we're dealing with fractions that 3 plus 1/2 you can write as 3 and 1/2. However, in algebra, when we see things written beside each other, it's understood to be multiplication. So this can cause some confusion if you leave it in that form, because people aren't sure, well, does that mean 3 plus 1/2, or is that a mixed number, or does it mean 3 times 1/2? So we're going to avoid doing that. Instead, we're going to work with improper fractions. So to add those, 3 plus 1/2, I need a common denominator, so that's a whole number is over 1, its denominator is a 1. My lowest common denominator is 2, so I change this to an equivalent fraction with 2 as the denominator. And to do that, I multiply the denominator by 2. I have to multiply the numerator by the same thing. So 3 is equivalent to 6/2. So 6/2 plus 1/2 will be 7/2. So my reduced or simplified expression is y to the 7/2. And that's preferable to writing 3 and 1/2. Okay, my next example, I'm allowed to take a power and raise it to another exponent. And the way I do that is I multiply by my exponents. So I'm going to have t to the 3 times 4/3. Multiplying fractions, quick review. If I have a whole number, it's over 1 times another fraction. The way I do it is I multiply the numerators, I multiply the denominators. However, I can cancel. If I have a factor that cancels into a number in the numerator and into the denominator, I can do that. So in this case, it's pretty straightforward. I have a 3 that goes into there, a 3 that goes into there. Now I multiply my numerators. Now I multiply my denominators. And 4 over 1 is 4. So this expression simplifies to t to the 4th power. All right, our next example involves division. We have fractional exponents, but the rule is still the same. We can divide by the rule that we used before. Because 1/2 is larger than 1/3, my result is going to be m to the 1/2 minus 1/3. And a quick review of fractions. When you're subtracting, you need a common denominator. You look for your lowest number that both of these numbers divide into. In this case, it's 6. So we write equivalent fractions with 6 as the denominator. The equivalent fraction here, I multiply by 3, do the same thing to the numerator. I multiply the denominator by 2 to get 6, I do the same thing to the numerator. 3 minus 2 is 1, so my result is m to the 1/6. All right. My next example is a product raised to an exponent, which I can apply to each of those factors, or I could simplify within. In this case, normally I simplify within, but I'm going to just work with this exponent first. So I'm going to apply that power of 6 to each factor. Keyword is factor. There's no addition or subtraction in here to make it a term, so I can do this. And we know that this means multiplication, so we have a to the 18th, b to the 1/3 times 6. That's like 6 over 1. I'm going to cancel a 3 into there, a 3 into there. 1 times 2 over 1 times 1, which is simply a 2. I'm going through this because sometimes students find they get lost on those kinds of things when they see examples, so I don't want to lose anybody. If that's more than you need, that's great. You just ignore me when I'm explaining. When I'm over explaining, just ignore. And the next factor, c to the -2 times 6 is -12. I don't like leaving, you're usually going to be asked to not express it with negative exponents. So how do we deal with that? Because these are all factors, I can simply put that in the denominator and it becomes positive. All right, our last rule deals with fractional exponents again, but instead of a 1 in the numerator, we have a number. So a to the m over n. I'm going to define what it means, and we're going to look at what it means in terms of numbers, but after that we're going to just leave it in this form when we're doing our simplifications. So this can be defined as in two different ways. We can say that that's equal to the nth root of a to the power of m. That's one way. We can also think of it as meaning the nth root of a to the m. Both of these are correct, and it depends on if you are working with numbers, it depends which definition works best. So for example, if I had 8 to the 2/3, if I take a look at the first way I've defined it, that means it's the cubed root of 8 squared. And that's equal to, cubed root of 8 is 2, 2 squared. So 8 to the 2/3 is equal to 4. I can do it using this definition as well. I can say 8 to the 2/3 is also equal to the cubed root of 8 squared, which is the cubed root of 64, 8 squared. Now, when you do this definition, it's harder to find the cube root of a larger number. That's why that might be easier, but the result is still 4, whatever way you go with it. If we had a negative exponent here, let's do this whole thing with a negative exponent. All right, let's say you have a negative exponent and we want to evaluate this. What we're going to do first is get rid of that negative exponent by taking the reciprocal. So this is going to be 1 over 8 to the 2/3. And we know that that's going to be 1 over the cubed root of 8 squared. And we know that that's equal to cubed root of 8, as I mentioned, was 2. So that's how we can evaluate a number when we have a fractional or a fractional and negative exponent. Let's look at some examples now of simplifying expressions having fractional, negative, any types of exponents. All right, let's take a look at some more examples. In this one, it looks pretty ugly, and I did that on purpose, but I went back to x's and y's to simplify it somewhat for you if you find x's and y's easier to work with. But really, we're following the same rules. It just looks uglier because we're dealing with a bunch of fractions. But we're dividing two powers that have the same base. Therefore, I follow that rule. And because 1/2 is larger than 1/6, I'm going to keep x in the numerator. So x will be to the power of 1/2 minus 1/6. Then I look at my exponents for y. Here it's 2/3, here it's 5/6. This is equivalent to 4/6, so the 5/6 is larger, so I'm going to keep y in the denominator. So it will be y to the power of 5/6 minus 2/3. And now we have to get a common denominator when we're adding fractions or subtracting fractions. So my common denominator here is 6, so that's going to be 3/6 minus 1/6. Common denominator here of 6. So it will be x to the 3 minus 1 is 2. 6, y to the 5 minus 4 is 1. And we don't want to leave 2/6. We always reduce our fractions, so it'll be x to the 1/3 over y to the 1/6. And that's our simplified result. Nothing else we can do with that. Our next example . Our next example is a reminder to not include our 5, or even if it was another letter, if it was an A, we don't include that with that exponent. That exponent only applies to the base of B. So we leave the 5 alone. We put B in the denominator because we're taking the reciprocal of our base, and then our exponent becomes positive. But what I sometimes see students do is they want to take the reciprocal of the exponent as well. No. The negative exponent means you take the reciprocal of the base, and once you do that, then the exponent stays exactly as it was, but becomes positive. Okay, so that would be simplified for that one. That's all we can do. Last two examples. Again, we can apply our exponent to each of those factors, because they're factors. So I have a to the 1/2 squared, b to the 3/2 squared. 1/2 times 2 is 1. 3/2 times 2 is 3. And you can do the multiplication out. I think I've demonstrated it enough, but you could go through and do that if you need to do that. So this would be our simplified result. Now our last example. I have a to the 1/2 plus b to the 3/2. Can I apply that power to each of those terms? I hope you said no. You cannot. I hope that has been helpful. The best thing for you to do now is to go and practice. Practice and practice. And if you have questions, look back at these examples, look at other examples, and hopefully it all falls into place for you, because you're going to see exponents further on in your math journey. All right, take care. See you on the next video.